Good morning. My name is André Mendes, and I'm the CIO at the Department of Commerce. The Department of Commerce is composed of a fairly large number of bureaus that have very diverse, types of charters, and a substantial amount of them is involved in supercomputing and artificial intelligence, and have been for a long time. And so it gives me great pleasure to be able to present, some general concepts about AI and quantum computing and supercomputing. Coming from a slightly different background. My background is in biology and genetics, in addition to technology. And so I would like to offer you a somewhat maybe different perspective than what you might have seen in this great conference that focuses on the future of humankind as it is affected by technology and artificial intelligence. And with that, I'm going to start sharing my presentation, and hopefully we can get going. Okay, so AI and quantum supercharging humanity. First of all, a few disclaimers. This presentation and the thoughts within it are mine and mine alone. No mention of a company, organization, or product constitutes an endorsement, of course. And in my opinion, it's time to think big. There are enormous changes afoot in terms of technology and what that means from a global standpoint in terms of macroeconomics and geopolitics. And the implications for civilization and humankind as we know it are tremendous. So it's time to think big about the opportunities and the challenges ahead. So let me start by sharing, some concepts about an accelerating evolutionary road. Prokaryotes, or singular cellular organisms, to sentiency was a process that took about 3.5 to 4 billion years. But from sentiency to Homo sapiens sapiens, our own species, it only took 7 million years. From Homo sapiens sapiens to ENIAC, which is generally accepted as the first general purpose computer, it only took 300,000 years. And from ENIAC to HPE Frontier, which is the latest and greatest supercomputer, it took only 77 years. Now, the question then becomes, from HPE Frontier to engineer sentiency, how long is that going to take? Well, it is a guess at this point, although some people believe very, very quickly. But the reality is that we have far shorter timelines with far faster progress, and a trend that it continues to accelerate. So, in terms of short-term expectations, we should expect that this will be an ongoing phenomenon that will dramatically change the way that we relate to each other and the way that we exist. Now, interestingly enough, at the same time, a very important component has been the rise in human longevity. If you look at Homo habilis, the typical longevity was 20 to 30 years. A brutish life with a lot of infant mortality, and of course the elements, because people were effectively at the mercy of nature by and large. In the Middle Ages, there was a little progress, but not much. Through agriculture, some medical knowledge, through trade, even one might argue some OBGYN, because the midwives started to come into play. There was a general agreement that the average lifespan increased from about 30 to 40, right? Now, even as recently as 1900 London, that life expectancy was 45 to 50, so not much higher, right? And then all of a sudden, nutrition, hygiene, and development medical know-how really started to make a difference. By 1950 in the US, it was around 70. With urban sewer systems making an enormous difference in terms of longevity. Water purity, antibiotics, vaccines, pasteurization, neonatality care also make sure that the longevity was increasing, right? By 2019 in the US, 78.9 was the average life expectancy. Modern medications, modern medicine, radiology, nutrition, safety, the genome, weather-related deaths being down by 90% by virtue of warning systems, which led then to, in 2020, the expected life expectancy actually coming down to 77.8, the first significant decline in a long, long time, mostly driven by COVID-19, drug use, and suicide, some of it as a result. Well, in 2050 in the US, what is the expectation? Well, a lot of scientists intimate at a potential for 120 in terms of life expectancy, but I am convinced that it will actually be a split environment where some people would be living much longer while others will only see marginal gains. A split amongst wealth levels, perhaps, because of the developments in technology. So at the same time that this is happening, we also see an inward migration into a different set of solutions, right? First, we dealt with environmental, like shelter and the availability of fire in the early stages. Then we saw external medical advances, amputations, excisions, tooth extractions that prevented people from, for example, dying of bacterial infections, right? As civilizational advances, now all of a sudden the society around you is changing, sewers and clean water systems, right? And then moving into the internal medicine with advances in antibiotics, chemotherapy, statins, vitamins, all the things that you are familiar with today. Now we get into a different realm in terms of intracellular therapies, endocytosis, peptides, viral vectors, nanoparticles. All of these are coming into the fold and driving incredibly advances in medicine. DNA and RNA altering techniques like gene replacement, gene editing, and gene silencing are now a part of the armamentarium of the medical profession, and that continues to make progress, right? And there is a new development that I will talk about a little bit later as well called CRISPR, which stands for cluster regularly interspaced short palindromic repeats, and that effectively gives us the ability to do editing of the DNA, and therefore either creating new functionality or being able to deal with deficiencies in the DNA of a particular individual with a particular condition. Now, how is this happening? This is being driven by infinite computational power. Let me show you a couple of examples. In 2001, the top 500 supercomputer leader was a computer called IBM ASCII White, and it performed at an amazing 7,226 gigaflops. Now, just for clarity, a gigaflop is a billion floating point operations per second, a remarkable number in terms of the capability of a computer back then. But you move 22 years later, and the top 500 supercomputer leader as of this November, so this past month, the HPE Frontier is performing at 1.2 exaflops. Now, that's 1.2 billion gigaflops, because an exaflop is a quintillion floating point operations per second. So effectively, it's operating at 1.2 billion gigaflops. Absolutely astonishing. And this is not going to stop anytime soon. The next generation of computers, Aurora and El Capitan, are expected to perform at 2 exaflops, so continuing to lead a massive increase in computation. And at the same time, while at the top there's this massive capability, at the bottom, the barriers to entry drop dramatically. So computers become cheaper and cheaper while offering tremendous computational power. What does this mean? A tremendous boom for open source efforts, especially in the AI arena. A rapid AI acceleration because there's so many players at the table innovating in a remarkable way with a tremendous amount of computing power at a lower price point. And of course, there are consequences to this. Not only are the generally accepted good people dealing with all of these innovations, you also have an equal boom for rogue operators, therefore creating some of the challenges that we expect as well. And this is, by the way, before quantum fully matures. And the maturation in quantum has been accelerating tremendously as well. As we're seeing, software support is exploding for quantum. Now, for those of us who've been around for a while around computing environments, what we're seeing is exactly the mirroring of what happened with supercomputing experience, where there were new programming paradigms, new software paradigms that were used in conjunction with standard computing and accelerated the process. We're seeing the same thing in terms of quantum computing, with hybrid platforms evolving with task divisions, where the interface to the human operators and to other computer systems are still in the old mode, while the actual computation and power is being driven by new quantum platforms. And so that hybrid interaction really leads to fast progress. Of course, fully encrypted quantum networking. One of the main issues with all computer systems, of course, is cybersecurity. The more important the computer system is, the higher the stakes are about protecting it, the more important it is to make sure that your cybersecurity is top-notch. And of course, encryption, especially when it comes to the quantum realm, is absolutely essential, because the ability of quantum computers to break standard old-fashioned encryption is now fully demonstrated. And so we can no longer afford to just have that as a fallback mechanism. Now, let me share with you a picture of a machine called a Peacock detector. It was put out by NASA and the Jet Propulsion Laboratory. And it is a remarkable piece of equipment, incredibly small, but that actually can detect photon hits in 100 trillionths of a second, which brings to the table a networking capability that is by any means extraordinary, even compared with the latest and greatest in normal network technology driven by bits. And of course, at the same time, leveraging distance entanglement, by now a well-known physics property, but that is now being leveraged in computing environments. Now, all of this is going to lead to quantum-driven machine learning acceleration. And it is already progressing at an incredible speed, right? But what we're seeing is with quantum machines, the ability to be far faster than the CUDA, the standard environments that we see today, and also the ability to handle far larger data sets. And of course, with faster and more sophisticated engines, with larger data sets, with all of those data points, what you have is a continued increase in the ability of AI to come to the forefront with really remarkable performance. And of course, quantum cloud provisioning. This is, it is the natural evolution of the cloud from standard computing to supercomputing, and now to quantum cloud provisioning, which effectively is the ultimate time-sharing environment. You can have access to massive, massive amounts of computation without having to have a massive investment from a capital standpoint. And then again, opens all kinds of doors for innovative players that can come to the table with a relatively small investment and really leverage the latest and greatest in technology, right? And of course, with the cybersecurity of quantum encryption, which, as I just mentioned, becomes paramount as the stakes become higher and higher, as technology pervades every single aspect of humankind. Unthinkable power on demand, but that's the way we have to think about it, because that's the reality that's facing us, right? The synergy between AI and quantum will literally change everything, from the clothes we wear to the vehicles we drive, to the way that we communicate, to the way that we think about the universe, and also the way we think about ourselves as human beings and the way that we deal with things like medicine. In the AI-driven medical nirvana, we move from genetics to epigenetics, the ability to really understand the interactions between our original genetic expressions and the environment around which they form and around which they happen. And that gives rise to who we are and how our bodies manifest themselves. From going from the genome to the proteome, a far more complex environment, to glycosylation, which is even more complex, right? And and doing away with the challenges of dealing with protein folding, where the latest quantum environments and AI environments are leading to massive increases in the ability to project and to understand the folding of proteins as a result of expressions of our genome. And of course, with this comes an optimized therapy progression. Initially, we dealt with compounds. We'd go out into nature, find a compound, and test it against all kinds of potential disease vectors to see if they had a therapeutic effect on them. And it was a lengthy process that went through massive amounts of testing. That took a long time, often 18 years, for the FDA to approve a medication, and it was extremely expensive, as much as 800 million for each new medication involved. Well, over the last 20, 30 years or so, we start seeing a progression to biologicals, where we actually are using, compounds that exist within our body already that make the transition into the clinic a lot faster, because a lot of the issues associated, for example, with noxious side effects can be dealt with or better understood. So, faster progression into market, and as a result, a faster progression into treatments and therapies, right? Now, lately, over the last 10 years or so, maybe 12, pharmacogenomics, started to come to the front, where a medication is done based on your specific genome. For example, Herceptin is very much targeted on an individual basis to people that have the HER2 expression, and as a result, it is become very, very targeted to that particular population. The future means individual formulations that are entirely driven by your unique, genome expressions. And at that point, we get into a completely different set of therapeutics that are highly, highly targeted to an individual, that therefore increase the efficiency and effectiveness of the medication while reducing the side effects, the potential side effects. And of course, one of the next realms of probability is DNA optimization. Imagine, for example, that we can, through genetic manipulation, look at the desirable traits. Things like eidetic memory, where you remember everything that happened in your past. Fast twitch muscles that allow runners to set 100-meter records on a regular basis. And even IQ, the ability to understand what in your genome creates these situations is without a shadow of a doubt going to create a situation where people will want to have a DNA optimization for those particular traits. And that might lead, before we know it, to the creation of superhumans that have all of these desired traits and none of the undesirable traits. Customized superhumans is just a matter of time, I believe, because the opportunity is there to really study in depth with AI and with quantum computing exactly what drives a particular type of gene expression, and as a result, the capability in a human being. Now, another science that comes into this, another technology that comes into this, and that also is going to be potentiated by both artificial intelligence and quantum, is nanotechnology and the ability, the opportunity to create nanomachines that will operate, even in environments as close as intracellular DNA regeneration, a concept that was first put out by Eric K. Drexler in a book called Engines of Creation in 1986. And that is becoming closer and closer to reality as all of these technologies continue to evolve. And of course, if you have intracellular DNA regeneration, not an easy process by any stretch of the imagination, what you could potentially have is immortality because of the regenerative effects on your DNA and the prevention of aging. A remarkable concept that seems to be a lot closer now than it was back in '86 when Eric first talked about it, but that nevertheless will have some degree of complexity associated with it over the next few years. Let me give you a couple of examples that deal with very specific conditions that are created by one gene or one protein. One of them is a condition called Leber congenital amaurosis 2. It's a mutation that lessens or eliminates the production of RPE65, one of the proteins essential for vision. It creates a problem where you have an inability to detect light, and as a result, you become blind. Well, enter Luxturna, where you can actually inject a healthy copy of a mutated gene, inject it between the retina and the epithelium in the eye, and have partial vision restored. Unfortunately, with this concept and with this medication, it is temporary. But if we need a permanent fix, enter CRISPR, and it fixes the DNA in the eye itself, therefore restoring vision. And trials are underway with advanced patients with very, very, very good results. Truly amazing how we're able to deal with these, simpler genetic-driven conditions, right? Another one, which has been in the news recently, is, of course, CRISPR and the sickle cell anemia, a disease that affects mostly African ascent individuals, that has an abnormal hemoglobin that impairs oxygen delivery, creates all kinds of horrible problems. And misshapen cells are stuck in the blood vessels, creating strokes, infections, arthritis, and pain crises that are incredibly, incredibly painful for its sufferers. Enter a new process called Exocell, CRISPR-based gene therapy that effectively edits blood-forming stem cells so that they have the ability to produce the right hemoglobin, right? Produce normal cells and restore functions. And this has been incredibly successful. 96.7%, 29 out of 30 patients were crisis-free in the first 12 months, and the subsequent results were almost as impressive. So remarkable, remarkable things. Many other opportunities for single-cell issues, and of course, more complex condition cures are sure to follow because, again, as this computational power increases, as artificial intelligence comes to the table with all the analytics around protein folding and other issues like glycosylation I mentioned before, we are no doubt going to be able to deal with multi-gene conditions and eradicate them from humankind eventually. So, what does this mean? Well, I like to call this evolution part deux. Okay, the evolution is and always been ruthless, right? From best of show to long forgotten is not as long at an interval as you might think. If you think about Australopithecus, right, at one time at the top of the charts, and then Homo habilis comes in and that fades away. Homo sapiens neanderthalensis comes in and becomes the top of the charts. And then, of course, we come in. Once the acmes, then the nadirs, and then extinct. And of course, this has consequences for Homo sapiens sapiens because we are the current acme, right? And so what happens? As we continue to see evolution, right? The next acme, something that I would like to call machina sapiens sapiens, where we really are leveraging interfaces with technology in order to increase our ability to deal with the world in general, with the universe in general, and to produce and perform at a much higher level. Look for pivotal signs, especially in the AI arena, in terms of compositional thinking, the meta learning for compositionality, which is absolutely common in human beings. It does not quite work yet in the AI arena, but it's right around the corner, and we're seeing massive progress because so much money has now been dedicated to advance that particular field. The maturity of wet interfaces. Now, we've had wet interfaces for a while now, where you can have, for example, cortex implants for hearing and for vision, right? But we're going to be looking at the next level, which is in terms of the ability to have processing capability and data access, not just sensory, added to our functionality through wet interfaces with the machine world at large, either specific computers or the internet or the overall universal communication system at large. And of course, leading to self-awareness, the holy grail of AI, which comes with all kinds of challenges and as well as all kinds of opportunities. The ability to express, feel, and act upon complex emotions, a unique human trait at this point, will without a shadow of a doubt be accessed in the near future, and eventually thought abstraction as well, with incursions into the arts and all of the things that make us the highest function in a species that has ever lived. Now, you have to ask yourself, philosophically speaking, right, this might not be good for Homo sapiens sapiens. But the reality is it inherently bad for the universe? And that is a remarkable question that we will be answering over the next couple of decades with an urgency that will be driven by the computational power that I've spoken of, by the continued increases in artificial intelligence and supercomputing and quantum computing, and the interaction of these three into a universe-changing technical capability that will both potentiate humankind or potentially threaten it. And with that, I thank you so much for your time, and I hope you enjoy the rest of the conference.